Have you ever stopped to think about what happens right after you click buy on a website? An order confirmation just shows up in your inbox. A shipping label gets printed in a warehouse, maybe hundreds of miles away. It feels like magic, right? Well, it's not magic. It's a system, an invisible messenger working behind the scenes. And today, we're going to pull back the curtain on exactly what that is, SAP's output determination. Okay, so let's get one thing straight right from the get-go. This is not just some techie behind-the-scenes detail. There's a golden rule among the pros, and it's pretty intense. If output determination fails, the supply chain stops. And no, that's not being dramatic. That's the cold, hard reality of how global business actually works. All right, so we know this is a big deal. Here's how we're going to break it all down. We'll start with why it's the linchpin. Then we'll get into its smart search, the decision rules it follows, how those rules become a reality, and finally, how to keep everything flowing smoothly. All right, first up, the supply chain's linchpin. I know linchpin might sound a little technical, but just picture it as the one essential gear in a massive machine that if it just stops, the whole thing seizes up. Let's dig into why it's so important. So what happens when this communication bridge just collapses? It's a domino effect, and it is fast. I mean, really think about this. No delivery note gets printed. That truck full of products, it is not going anywhere. The system can't email the invoice? Well, your company's not getting paid. Your customer is just sitting there in the dark, wondering what happened to their order. And your shipping partners? They've got nothing, no data. It's this one single point of failure that can literally stop products from moving, stop money from coming in, and just shut down all communication. So how on earth does a company avoid this kind of disaster, millions of times a day? Well, it uses this really smart engine called the condition technique. The best way to think about it is like a detective, a super focused detective whose only job is to find the perfect communication rule for every single transaction, and to do it without ever making a mistake. Yeah, this condition technique is pretty much the brains of the whole operation. It's an automated system that just asks a series of questions to figure out the right thing to do. So instead of some person having to remember, oh, email this customer, but print a label for that one, the system has this built-in strategy to make the right call every single time. Now, our detective isn't just wandering around looking for clues. Nope, it has a very specific search plan, a protocol called the access sequence, and it always goes from the most specific to the most general. So first it asks, is there a super specific rule just for this one customer? If the answer is no, it takes a step back. Okay, how about a general rule for this whole sales group? And the second it finds a match, bam, the search is over and the instruction is carried out. It's just unbelievably efficient. Okay, so what's in our detective's toolkit? What are these rules actually made of? Well, it comes down to 4 key pieces that all have to fit together just right. Let's take a look. This table lays it all out for us. Think about it. Every detective case starts with a clue, right? That's your condition table, something specific like customer number 1234. The plan to find and check that clue? That's the access sequence we just talked about. Once you've got your clue, you need to know what to do. That's the output type. For example, email the invoice. And where do you keep all this stuff? In the case file, which in the SAP world we call the procedure. Okay, so that's the theory. But let's get real. How does all this go from being a set of rules on a screen to something that actually happens in the real world? You'd be surprised how a few simple choices here can have a huge impact on the business. One of the first big questions you have to answer is, when does the message go out? You've basically got 2 main choices. You can send it immediately, the second someone hits save. And, that's great if you're testing something or for a really urgent message. But if you're a big company doing thousands of these, sending them one by one can seriously bog down the system. That's why most places go with option 2. Send it later in a batch job. The system just gathers everything up and sends it all at once, which is way, way more efficient and keeps everything running smoothly. Now, this next part is maybe the most important takeaway of all. I love this analogy. You can build the most incredible, high-tech car in the world. Perfect engine, perfect design, but if you don't put any gas in the tank, it's just a really expensive lawn ornament. It is not going anywhere. In our world, that fuel is called master data, or condition records. This is where you connect the rules to the real world. It's where you tell the system, okay, for customer 1000, I want you to email them at this specific address. If you don't do this part, all that beautiful configuration we talked about, it does absolutely nothing. All right, so let's wrap up with 2 final things. First, what happens when things inevitably go wrong? How do you fix it? And second, where is all of this technology going? What's next? Okay, if you remember one thing about troubleshooting, please let it be this. When a message doesn't pop out like it's supposed to, there's a button. It's called determination analysis. And this isn't just a button, it's the button. It's like a black box recorder for your transaction. It shows you everything the system tried to do, step by step, and tells you exactly where and why it failed. It completely takes the guesswork out of the problem. And of course, this stuff doesn't stand still. The classic way we've been talking about, using that old NACE transaction, is all based on that very strict detective search plan. But now, in the modern S/4HANA world, things are a lot different. The new way uses something called BRF+, which is basically a set of flexible decision tables. So think of it like this. Our detective went from following a simple checklist to using a powerful AI that can weigh a bunch of different factors all at once. And the biggest win here? The business folks themselves can often tweak these rules without calling IT, which makes the entire company so much more agile. So there you have it. This complex, invisible logic is truly the engine that powers global trade. We've seen it evolve from these rigid, fixed paths to much more flexible, intelligent rules. And it really makes you think, doesn't it? With the next big shift in technology, like real AI, what happens then? Will this critical messenger actually start to think for itself? Could it one day predict what a customer needs and just send it, even before they think to ask?